Hi there. In this video, we are going to go over how to compare and order real numbers. So first things first, we are going to start off with pi squared plus 1. So in order to approximate pi squared, we already know that pi is 3.14, right? About 3.14. But I'm going to make it so that pi, for the sake of this, since we're just approximating, I'm going to approximate it to be even simpler and say 3.1. All right, and then I'm going to multiply that. So 3.1 times 3.1. And then I get 1 times 1 is 1. 1 times 3 is 3. 3 times 1 is 3. 3 times 3 is 9. So I have about 9.61, or again, since this is all approximating, I'm just going to write 9.6. Then I drop down that plus 1, and now I have 10.6, right? When I add 9.6 plus 1, I get 10.6. So this answer is going to be about 10.6. So if you have somewhere around the same, then your answer is correct. All right, so next. We are going to approximate the square root of 10 plus the square root of 27. So the square root of 10 is between the square root of 9 and the square root of 16. Right? The square root of 9 is 3, and the square root of 16 is 4. So square root of 10 is way closer to the square root of 9 than the square root of 16, right? By a lot. So this is going to be about 3.1. Then if we look at the square root of 27, right? So the square root of 27, that is between the square root of 25 and the square root of 36. So the square root of 25 is 5. The square root of 36 is 6. 27 is way closer to 25 than it is 36, right? So the square root of 27 is way closer to the square root of 25. So that means it's way closer to the 5 than it is to the 6. So I'm going to approximate this to be about 5.2. If you have something around that, then you are okay. All right, and then we're going to add 3.1 plus 5.2, and we get 8.3. All right, next we have the square root of 101. That falls between the two perfect squares of the square root of 100, which is 10, and the square root of 121, which is 11. It is way closer to 10 than 11, so I'm going to approximate it as 10.1. And then this 3 squared, right, is 3 times 3, which is 9. So I'm going to add 9 to that, and I have now 19.1. All right, so next, number 4, I'm going to graph and approximate the approximate location of where 123 would be, the square root of 123. All right, so 123 is between the two perfect squares, 121 and 144. So the square root of 121 is 11. The square root of 144 is 12. So we are between the whole numbers 11 and 12, or the square root of 121 and the square root of 144. So 123 is closer to 121 by a lot compared to 144, right? So if we were to graph this, it would be somewhere over here. And that point would be located at about 11.1-ish. You could say 11.2. I probably wouldn't go past 11.3 for your estimate because this is pretty close to the 11. All right, number 5, we have 2.5, so that is 2.5, and the square root of 10, which the square root of 10 falls between the two perfect squares, square root of 9 and the square root of 16. So that's 3 and 4, right? Square root of 10 is way closer to to the square root of 9 than it is to the square root of 16. So therefore, the square root of 10 is closer to 3 than it is 4. So I'm going to approximate the square root of 10 to be about 3.1. And now we can compare 2.5 and 3.1. 2.5 is less than 3.1. All right, for the next one, we have the square root of 15. The square root of 15 is between the square root of 9 and the square root of 16. The square root of 9 is 3. The square root of 16 is 4. All right, well, the square root of 15 is closer to the square root of 9. Oh, sorry, it's closer to the square root of 16 than it is to the square root of 9, right? 15 is only 1 away from 16. So this is going to be about 3.9. And we're comparing that to 4.8. Well, 3.9 is less than 4.8. All right, so for the next one, we have 3 plus the square root of 60. The square root of 60 falls between the square root of 49 and the square root of 64. The square root of 49 is 7, and the square root of 64 is 8. So the square root of 60 is about 7.7, 7.8, right? It is closer to the square root of 64 than it is the square root of 49. So we are a little bit closer to the 8 there. So I'm going to approximate this to be 7.7, and then I'm going to drop down that 3. And 3 plus 7.7 will get us 10.7. So we are comparing 10.7 to, if you can recall a number 1 of these notes, we had pi squared already done, and we approximated that to be 9.6. If you don't know, we just did 3.1 times 3.1. And then 1 times 1 is 1, 1 times 3 is 3. And then same thing, 3 times 1 is 3, 3 times 3 is 9. And we got 9.61, so I'm approximating it to be 9.6. And now we're comparing 10.7 and 9.6. 10.7 is in fact greater than 9.6. All right, number 8, we are comparing, we are ordering from least to greatest. So the first thing I'm going to do is I'm going to figure out what these square roots are. So the square root of 143, this falls between the square root of 121 and the square root of 144, right? So it falls between 11 and 12. 143 is way closer to the 12 than the 11, so I'm going to approximate this to be about 11.9. The next one, the square root of 121, actually this is a perfect square, right? Square root of 121 is 11, and then we're comparing it to 11.1. Now something important that you need to know, this 11.1 in the front here, this technically is 11.100000, right? There's a whole bunch of zeros at the end of that. This 11.1 has the repeating bar over it. So what that means is instead of zeros being at the end or after that 1, this repeats, this 1 repeats. So we have 1s behind it. All right, and now we can put these in order from least to greatest. So the least would be 11, right? 120, the square root of 121. So least is square root of 121. All right, next, we are comparing 11.100, 11.9, if it helps you, right? This has zeros behind it, and 11.111. So 11.100 would be next, or just 11.1. All right, next we are comparing 11.9 versus 11.1 repeating. So the 11.1 repeating is next. And then we have our last but not least, the square root of 143, which is about 11.9. All right, and then number 9 says we're going to order them again from least to greatest. So 5.5, I'm going to turn that into a decimal of 5.5. This is already 5.7. The square root of 26 is really close to the square root of 25, right? The square root of 25 is 5. So the square root of 26 has to be a little bit bigger than that. So I'm going to approximate this to be 5.1. And then we have that outlier of 30. All right, so when we go to order these from least to greatest, the least is this 5.1 or the square root of 26. Next is the 5.5. All right, next is 5.7. And last but not least is the outlier of 30. All right, so that is all. Thank you for watching. I hope you learned how to compare and order real numbers.